So let's look at the top view of the prism. It's a hexagonal prism. So something like this. Each edge measures 6 inches. So the area can be determined, area of base can be determined. So remember the volume of any solid object, which is a prism. Prism is a solid whose bottom and the top are congruent. Okay, so the same bottom as the top, this is a prism. The volume of any prism is always area of base into height. That's the area of prism. In case of a pyramid is a solid with a pointed top. In that case, the volume is 1/3 area of base into height. Okay, so let's deal with this one. So for this, we need the area of base as well as height. This doesn't talk about height, so this cannot be sufficient. This talks about the height, but this doesn't talk about the area of the base, so this cannot be sufficient. On combining, I know that the area of base can be determined, and I know that the area of the height is also there, so the volume can be determined using this. So together it's going to be sufficient. If this question appeared on the GMAT and I were attempting the GMAT, I would not take the pain of finding out what value that is. I would just mark option C and proceed. However, for the sake of conceptual clarity, if this were a PS question, let me still solve this question and show you the value. So now this is a hexagonal prism. Each side measures 6. So see, everything therefore would measure 6 by symmetry. This is going to be a set of 6 equilateral triangles. The area of one equilateral triangle would be root 3 by 4 a square. A is 6, 6 square, 36 upon 4, 9. Area of one triangle is going to be 9 root 3. There are 6 such triangles. So the area of base is going to be 54 square root 3. That is the area of base. So volume is going to be 54 root 3 into the height, which is suggested as 4 into 4. The volume is going to be 216 root 3 square inches. Again, this value is not important here. This is just to explain. Practically what matters is that together we'll get to a unique answer. Therefore the answer is option C.